Hi, my name is Kaneshiro, and my project is on reshaping plastic waste, developing a mechanism that would transform single-use plastics into 3D filament. So, what's the problem? The problem is that plastic waste poses a growing environmental challenge, especially in Hawaii, where disposal and recycling options are limited. This project aims to design a mechanism that converts plastic waste into 3D printing filament, promoting sustainability and circular use of materials. The system processes plastic through shredding, melting, extrusion, cooling, and spooling, turning discarded plastics like PET and PLA into reusable filaments for FDM printers. Key design parameters include maintaining precise filament diameter, about 1.75 millimeters, controlling extrusion temperature and speed, ensuring consistent melt flow, and optimizing energy efficiency. Developed as part of an engineering design course in Hawaii, this project integrates mechanical and thermal design principles with local sustainability goals. By reusing waste plastics for digital fabrication, it reflects the value of Malama Aina while providing students with hands-on experience in sustainable engineering innovation. So this first figure is the initial sketch of the mechanism, and the second figure is the cat that I made of the mechanism. So for design, taking inspiration from the existing designs found in the research, the concept for the mechanism was conceived in the initial sketch from before. And to create 3D filament, this prototype utilizes the hot end, where plastic strip sourced from PET bottle is pulled through a nozzle with a motor and gear. This vertical orientation reduces the overall space requirements, allowing the mechanism to fit into more confined areas. The force of gravity, complemented by the motor, contributes to the seamless winding of the filament into the roll. So this third figure is a deconstruction ender 3, which I bought in order to make the mechanism. And the fourth figure is the first prototype of the mechanism. So across multiple trials, variables were adjusted, determined the optimal conditions for producing printable filaments that meet the required design constraints. So this is the data table that would test the multiple variables. Sadly, I wasn't able to actually get to the testing section. My first prototype actually didn't work. So for conclusion and future work, in the next phases of the project, the focus shifts towards finalizing the first prototype. This involves 3D printing and assembling the components extracted from the CAD onto the pre-existing base of the mechanism. Once this initial prototype is completed, a collection of data can start through further prototyping and rigorous testing. So this last figure is a 10-to-1 ratio gear put onto a stepper motor, which would spool the plastic into making the filament. These are my references, and I would like to acknowledge my professor, Hanai, for his guidance and support throughout this project. Thank you.